Hi, I'm Phil Porras, the Chief Scientist at Accuknox, and I'm also the Program Director of Internet Security Research at the Stanford Research Institute in Menlo Park, California. In this presentation, I'll give an overview of the new technologies our team is developing to help protect and manage sensitive data in Kubernetes environments. The work I'm going to describe is based on more than a decade of research conducted by SRI's Computer Science Laboratory. SRI has been exploring an area of computer security called data provenance, which involves the design of methods to audit the origin and flow of data within computer systems. Using our provenance systems, we can answer basic questions such as these, all of which basically involve tracking how data flows between processes and data objects within computer hosts. Inside Accuknox, we're now developing a novel provenance-based policy engine capable of sensitive data flow tracking within Kubernetes clusters. The system is designed to address two critical trends: the need to protect sensitive data that is being increasingly processed in data analytic pipelines, like in machine learning applications, and second, the need for these applications to meet stringent data governance compliance requirements. Our team is developing a fine-grained data flow tracking engine that will deliver in-depth live data governance over all the sensitive data flowing through a container ecosystem. The work we're doing here is derived from SRI's SPADE system, which is a multi-operating system provenance framework for tracking the origins of all data stored within a computer system. SPADE has a substantial codebase, and many provenance researchers have contributed to it over the last decade. I should note here that SPADE's provenance model is based on an interpretation of the open provenance model that was published in 2007. To help illustrate provenance, let's go through a quick example using a provenance graph that is being built from an operating system audit trail. Let's consider the blue boxes to represent processes and the yellow ovals to represent data objects, such as files. We can also view the graph as representing a timeline of actions. Here the graph shows actions that occur in sequence from time t0 to t7. Let's also assume that two of our data files contain sensitive data, which are labeled here as sensitivity labels L1 and L2. Finally, I've color-coded the arcs to represent read operations in the green arcs and write operations using the red arcs. In this simplified example, the provenance engine can automate the taint tracking of data as it flows among data objects and processes, tracking the data flows as the read and write sequences occur. While this is a simple example, it illustrates the basic concept. Here in Accuknox, we're adapting SRI's SPADE provenance framework to create a new class of live data governance services for container ecosystems. We're calling our provenance engine the Knox Data Defender, and it will introduce specialized sensors to analyze data flows across Kubernetes workloads, pods, and clusters. We're also developing unique use cases and services above the Data Defender to address a wide range of security compliance requirements and alerting services for when data handling policy violations occur. The Knox Data Defender employs an eBPF-based or extended Berkeley packet filter-based system call auditor to conduct process-level data provenance tracking within the container. These records are augmented with kernel metadata beyond standard eBPF forensics, enabling us to do fine-grained data flow tracking per process. Our system will track sensitive data delivered to and from backend web services, and it will perform multi-container provenance coordination. It will also reconcile data flows from cloud-based data access brokers into the container provenance graph, as well as track sensitive data accesses to and from backend databases. Our intent is to enable pod and cluster administrators to track exactly where critical data propagates across their container pipelines, as well as to where this critical data may exfiltrate. Finally, here's a quick review of the kinds of validation metrics that the Knox Data Defender should be able to address. Given a sensitive data object, such as one containing patient private data, it will accurately identify all sensitive data objects within the container and cloud stores that are tainted with this data. Given a data object, such as a file, it will identify all sensitive data labels with which the file is tainted, and similarly, given a specific container process, it will identify all the sensitive data labels with which the process is tainted. And finally, given predefined alert criteria, for example, a policy to alarm when sensitive data may flow to a prohibitive data store, it will accurately produce a data flow policy violation alert. As industries continue to push more sensitive analytics into the cloud, our Data Defender will enable them to address the growing data governance requirements for compliance standards like PCI, HIPAA, GDPR, and others. Well, that's a quick overview of Accuknox's emerging deep data governance system. If you'd like to learn more about this and some of the other technologies that Accuknox is developing, you can reach out to me through email or on LinkedIn.